fellow SREs. Welcome back to SRE with Ben. Today we're going to learn about monitoring Kubernetes using the cluster operator and cluster agent. So today we'll be only looking at how to monitor a Kubernetes cluster. In future videos, we'll be looking at how to monitor the worker nodes in a Kubernetes cluster and other APM related to Kubernetes. To understand how to monitor Kubernetes, first you would have to understand the architecture of Kubernetes. Before you get started with this video, if you don't know much about Kubernetes, I suggest that you go watch some YouTube videos to understand how the architecture of Kubernetes is, what is a pod, what is a deployment, all the basics, then come back to this video. If you already have an idea about Kubernetes and its environment, you can go ahead with this video. Appdynamics gives us an option to monitor a Kube8 cluster via two components. First, you will have to install the cluster operator on your Kubernetes cluster. Then you would have to install something called as a cluster agent to monitor the cluster. We'll be going through the steps to install both of these components in your Kube environment. Before that, there are some prerequisites that need to be verified so that your cluster operator and cluster agent can work as expected in your Kube environment. For that, let's go to the cluster agent requirements and check what are the requirements that we need. First thing is you need to have something called as a metric server deployed on your Kube environment. Metric server acts as an interface between your Kube master node and your Appdynamics operator to give you the various metrics that you're trying to monitor. For example, pod metrics, your node metrics, etc. To verify if metric server is already deployed as part of your Kube environment, you can check that by running the kubectl top command. Here you can see this command requires metric server to be correctly configured and working on the server. To check whether the metric server is available, we can check whether the pod and node metrics are displayed along with the top command. And you can see my node metrics have been displayed here. This means that my metric server is already deployed. If the top command does not give you any data, that means your metric server is not set up properly. To set up the metric server, all you have to do is follow a few simple steps. Go to this link from the documentation. It will take you to the GitHub part of metric server deployment. Here you will have all the instructions on how to set up the metric server. To install metric server, all you would have to do is run this command to apply the metric server deployment. If you're trying to set up the metric server in a local Kubernetes environment, you would have to override a self-signing certificate checking part. To do that, download this deployment file. Navigate to the part where arguments are defined, your container arguments, and add this line to override secure TLS checking. Once you do this and deploy the metric server, it should deploy as expected. If not, you will get an insecure certificate issue. I have done this setup. I have downloaded this file, added this argument, and ran the apply command with kubectl. Now I can see that my kubectl top command is working as expected. This means that my Kube environment is ready for Appdynamics operator and cluster agent deployment. Once this prerequisite check is done, we can start with deploying the Appdynamics operator. For that, navigate to this link where the steps are provided. First thing we would have to do is create something called as a namespace for Appdynamics. A namespace is type of an isolation in Kubernetes where you can use namespaces to group related components together. Since we'll be deploying Appdynamics operator and cluster agent, we are creating a namespace called as Appdynamics, and we will be deploying the agent and operator under this namespace so that it's isolated from the other Kubernetes pods and other required agents. First, I'm going to create the namespace Appdynamics. You will get a message saying namespace Appdynamics created. Normally, when you run kubectl commands, it runs in your default namespace. To change your namespace, you would have to run the kubectl config set context command. So I'm going to do this and change my namespace to Appdynamics, which I just created. Now you can see my namespace has been modified. You can also verify if the namespace got created correctly by running the kubectl get namespace command. Here we can see that Appdynamics namespace has been created. It's been 2 minutes since I created this namespace and it's an active status currently. After the namespace is created, we can go ahead with the operator installation. For that, we would have to first download the cluster agent bundle from appdynamics.downloads.com. I have already downloaded the cluster agent bundle from downloads.com, and this is how the structure of the zip extract is. So here, what we'll be concentrating on for today's video is the cluster agent operator.yml and the cluster agent.yml. Before deploying the cluster agent operator, let's understand what is happening in this YAML file. So there are certain components and permissions that this cluster agent operator deploys in your Kubernetes environment for the operator to run. The first thing is there are certain custom resource definitions that it deploys along with your cluster operator for your operator to run successfully. You can go through the specs if you're interested. Then if you know Kubernetes, you know that any type of daemon set or monitoring agents to run, you need three components. One is your service account, then you need a role, and you need a role binding to bind the service account and the role. So what is a service account? A service account is basically a user that your operator uses to run commands in your Kubernetes environment. So there are certain permissions that the operator needs to access the metrics information. For that, you create a service account called the Appdynamics operator, and you assign some roles to it. So the roles will have all the required permissions to get and watch the pods. These are all the components on which you can perform these actions. So when you run the get request on pods, it will give you all the metrics related to that pods. This role will be binded to your service account. So here you see this role binding where the Appdynamics operator service account is bound with the Appdynamics operator role. And this service account will be used by your Appdynamics deployment to run the activities and send the data to Appdynamics via the cluster agent. Since you've come so far in this video, I hope you already understand what a deployment is. Your Appdynamics operator is deployed as a deployment in the cluster, and it runs along with your cluster agent to report the metrics to Appdynamics controller. Now that we know what is there in a cluster agent operator, let's go ahead and install the cluster agent operator. To create the cluster agent operator, Appdynamics tells you to run a create command along with the cluster agent operator YAML. Let me run the create command. Once you run the create command, you'll see some lines like this where it tells you all the resources have been created. Like we discussed, the service account, Appdynamics operator is created, the required role and the required role binding is created, the deployment for Appdynamics operator is created, and a couple of other service account along with the role binding is created. Let's verify if the operator got installed successfully. Let me run a kubectl get pods. I can see that the Appdynamics operator has been installed successfully and it's in running state. Let me check the logs for this pod. Now we can see there are no errors in the operator logs. That means the operator is working fine and it's waiting for a cluster agent to send the data to Appdynamics. Next step is to deploy the cluster agent. As part of your cluster agent bundle, we have the cluster agent YAML. We'll have to add few details in this file. First thing you would have to add is the app name. So let me give this app name. Now we need to configure the controller related information. So first let me get my controller URL, and the port will be 443 since this is an HTTPS URL. Then I would have to give the account name. To get the account name, navigate to your licenses, navigate to account. Here we have the account name. Post this, you need the image details. I got the image details from Docker.io. This is the latest cluster agent version. If you have a local repository or an organization internal repository, you would have to give that details here. Once this is done, save this file. We are ready to deploy the cluster agent. One more step that we would have to perform before deploying the cluster agent is to set the secret key, because your agent will need the account secret key to connect to your controller. For that, we have to run this command along with the secret key. So copy this command from documentation and insert your access key here. To get the access key, again navigate to your Appdynamics controller, license, account. What this command basically does is it creates a secret called a cluster agent secret with this value. This will be accessed by your cluster agent to communicate to your Appdynamics controller. Now that we are ready to deploy the cluster agent, let's go ahead. We just have to run this kubectl create cluster agent YAML. We are in the cluster agent folder, and we'll run this command. Now we can see that a message saying cluster agent has been created. Let's verify if the agent got created successfully. Now we can see that the Appdynamics cluster agent has also been created. Both the required resources have been deployed in your Kube environment. Let's verify if the cluster agent is running as expected. We can see that the cluster agent is running. Now you see a 403 forbidden error since I don't have a cluster agent license to report to my controller. It's part of trial version. If you have the license, this will report successfully to your controller. Since I don't have a license, I'm not able to show you the view. Once both the components related to Appdynamics monitoring is running successfully, you can verify whether it's reporting to the controller by navigating Appdynamics servers and navigate to your cluster part. Since I don't have any license, I won't get any information, but you can see that my cluster agent has started reporting. You can see that that agent is reporting, and it will show you all the details related to that cluster. This is how we set up cluster monitoring for Kubernetes using Appdynamics. Just to reiterate, Appdynamics cluster agent is used only to monitor the Kubernetes cluster. If you would want to monitor the individual worker nodes, then we would have to set up something called as an infravis, and this will use the machine agent license to monitor your worker nodes and report to Appdynamics. So you need a separate license for each worker node running in your cluster. We will be seeing how to set up the infravis for machine and network monitoring in the upcoming video, and also how to implement APM for applications deployed in Kubernetes. With this, we have come to the end of this video. Hope you enjoyed today's content. If you find my content useful, kindly do subscribe to my channel. I encourage you to share it with your colleagues and friends who are working in Appdynamics so that they can also benefit from these videos. Thanks for watching. Happy learning.